We all know that California is in a severe state of drought, with this year being the second driest on record. But did you know that California's water is needed to support over 37 million of its residents, as well as still be the second largest rice producer in the country? Which is interesting to say because rice is one of the most water intensive crops to grow, for its needs in water is not just for consumption, but also to act as a natural pesticide and herbicide to weeds. This project focuses on reducing the amount of water needed to grow rice using Brassinolide, a plant growth hormone. The goal of this project is to determine what concentration of Brassinolide could reduce rice's water intake without affecting the growth or cause unwanted side effects. The project's hypothesis is that a 10% concentration of Brassinolide, as suggested by the Brassinolide supplier, produces the best plant growth as supposedly won't affect the water intake and hopefully reduce the water intake. To do this, rice seeds were soaked for 40 hours and allowed to dry for 24 hours before transferring them to a plastic container for germination. When root length reached 5 millimeters, or about 5 millimeters, the seedlings were transferred into one of six concentrations of Brassinolide solution, the control 0%, 6%, 8%, 10%, 12%, and 16%. When plant stems grew to about a 0.5 millimeter diameter, water intake was measured with a photometer modified to hold the whole plant. Also, PCR was conducted to identify an unknown beetle that was causing some of the initial seeds to be removed from this experiment. The result did not support the hypothesis. Instead of a 10% solution, the 16% solution showed the highest water reduction as well as the higher growth rate compared to the control group of seedlings in the 0% solution. The better performance of the 16% solution compared to the 10% solution is possibly due to the higher concentration of Brassinolide being able to react with the plant, as well as the other factors such as like mold that was affecting the seedlings in other concentrations. Other than mold, this study was also negatively affected by the lack of heat and the rice weevil that was the unknown beetle that was identified earlier. Although mold negatively impacted the plant's growth rate, it also exposed the role of Brassinolide as a fungicide, helping moldy seedlings survive mold even though they were growing at a slower rate. This finding prompted future studies to investigate more on using Brassinolide as a fungicide, as well as testing even higher Brassinolide concentrations to find the optimal concentration level to reduce the water intake without penalizing the plant's growth rate. Although there is not a perfect solution to get California out of its drought, further research on creative farming, such as this study that uses less water, is desperately needed to allow farmers to take advantage of California's year-round warm weather, which makes it perfect to grow crops. Thank you.